Hello everyone, welcome to the second international conference on accepts of material and mechanical engineering. Thanks for giving me this opportunity. Myself Smriti Pradhan from Department of Civil Engineering, Rajki Engineering College, Mainpuri. My topic is soil stabilization through the application of waste fiber materials. The outline of my presentation is introduction, objectives, material used, methodology, result and discussion, conclusion, references. Introduction. Soil stabilization improves the load bearing capacity of soil, making it stronger and more durable, which is crucial for construction purposes such as roads, buildings, and foundation. It basically increases the strength and load bearing capacity of the soil. As we know that population increases continuously, so the generation of waste is also increasing continuously. On an average, India produces about 3.4 million tons of plastic waste in a year and only 30% is recycled. Plastic generation has increased in India over the past 5 years. Also, the pandemic created a surge in plastic products like online shopping, food delivery services, which all generally involves plastic fiber material and plastic packaging. So in this research, we use plastic fiber material. The disposal of diverse waste material generated by various industries constitutes a significant challenge, contributing to environmental pollution in the vicinity due to the presence of non-biodegradable waste. Recycling materials is cost effective and environmental friendly, so it is helpful in the research into their use as a stabilizer for soil projects. Objective of study: evaluate the effectiveness of waste fiber materials, investigate the optimal dose and mixing techniques for incorporating waste fiber materials into the soil to achieve enhanced stability and strength. Study the potential application of waste fiber materials in specific soil stabilization scenarios. Explore the influence of waste fiber materials properties on soil stabilization performance. Investigate the geotechnical and mechanical properties of soil fiber composition. Methodology. There are two methods for soil stabilization: physical and chemical. Physical method is the oldest technique for stabilizing soil. Our physical one. It involves physically changing the properties of the soil by dynamic compaction and vibration compaction. Chemical methods rely on chemicals or introducing a new substance into the soil that will interact with it physically and alter its characteristics. For example, limestone, cement, fly ash, clean dust. Materials. Properties of the soil sample. Soil type Cl. It includes gravel clays, sandy clay, silty clay, and lean clays. Natural moisture 48%, liquid limit 48.2%. Liquid limit is a water content where the soil starts to behave as a liquid. Plastic limit 28%. Plastic limit is a moisture content at which a fine grained soil can no longer be removed without cracking. Plasticity index 20.2%. Plasticity index is a difference between the liquid limit and the plastic limit. It is a range of water content over which the soil remains in the plastic state. Specific gravity 2.48. Specific gravity is a measure of the density of a substance in comparison to the density of water. Optimum moisture content 22.48%. Optimum moisture content is a moisture content at which the soil attains maximum dry density. Maximum dry density 17.4 kilonewton per meter cube. It is the peak dry unit weight. Material. Plastic fiber. Plastic fiber were created by repurposing waste plastic covers, notably milk and curd packets. These plastic covers were thoroughly cleaned and air dried before being shredded into fibers. Most people consider these plastic covers to be the disposal rubbish, but it is not. Results and discussion. As I have told you earlier that optimum moisture content is a moisture content at which the soil attains the maximum dry density. In table, it is depicted how soil sample treated with 0.5%, 1%, 1.5% plastic replacement varied from untreated soil samples in terms of maximum dry density values. Notably, the soil samples with 0.5% plastic replacement increased its maximum dry density from 1.29 to 1.383 compared to the untreated soil samples. However, the value decreases after this point. The reduction in voids caused by the inclusion of plastic is attributable to the maximum dry density rising. Improved compaction results in the lower optimum moisture content and a higher highest dry density. So it is all depicted in this table. In this graph, it is the results of Proctor test. Proctor test is performed to determine the optimum water content at which the soil can reach its maximum dry density. Curve was plotted for dry unit weight as a function of the water content. For this curve, the optimum water content to reach the maximum dry density can be obtained. In this graph, it is clearly visible that when we increase the plastic, maximum dry density is also increasing. But when the plastic content reach at a certain limit, the value of maximum dry density decreases. Results and discussion. Compressive strength. Compressive strength is the capacity of soil to withstand loads before failure. Tests were performed on samples that have not been treated as well as samples where plastic fiber had replaced 0.25%, 0.50%, 1.25%, and 1.5% of the soil, respectively. The tests were performed according to the procedure available in IS 2720 Part 7, 1918. Both confined and unconfined compressive tests were performed along with a typical Proctor test. The results of these two tests were listed below in table. This graph indicates the relationship between the plastic percentage and compressive stress. Here, the unconfined compressive strength is the total load per unit area at which an unconfined cylinder specimen of soil will fail in the sample compression test. In this graph, it is clearly visible that when we increase the plastic percentage, compressive stress also increasing. But when the plastic content reaches at a certain limit, the value of compressive stress decreasing. Conclusion. This study aims to evaluate the effectiveness of plastic fiber in soil stabilization. The study shows that when we properly planted and applied, plastic fiber can be highly effective soil stabilizing method. The following are the initiative principal findings. The expanding clayed soil optimum moisture content was decreased and the maximum dry density was increased by the replacement of 0.5% plastic fibers. It was discovered that soil unconfined compressive strength has improved by 0.5%. It was shown that the maximum dry density and unconfined compressive strength were more than the untreated soil with 1% replacement but less than 0.5% replacement. As the plastic replacement was raised further, the maximum dry density and the soil unconfined compressive strength declined. The ideal plastic content is suggested to be 0.5% based on the non-problematic soil criteria, which will enhance the silty clay engineering properties. Following are the references of my research. Thank you.